Algebra II 4.2b, Linear Combinations and the Elimination Method. If you haven't seen the previous videos for Chapter 4, you might get confused. And there's links in this video's description to go to 4.1 and 4.2a so you can watch them very quickly, okay? If all the variables in a system of equations have coefficients that are other than 1, our friend the invisible 1 that we used in the last video, well, if the coefficients are other than a 1, we can use the multiplication and addition properties of equality to find a combination of the linear equations that will eliminate a variable. We call this the method of linear combinations, okay? And when you see two equations with a brace sign on the left like that, it's telling you that it's a system of equations, all right? So we can use linear combinations to solve this system. We've got 3x minus 4y equals a negative 1, and we've got negative 3x plus 2y equals 0. And we can see that the left side of the first equation equals the right side of the first equation, right? This is equal to this. It's balanced. So we can add this 3x minus 4y to the left side of this equation and the negative 1 to this side of the equation. And this positive 3x and this negative 3x right here, when we stack them, that's the easiest way to do this, is to stack them. We can see that they're additive inverses and they're going to create a zero pair. We're going to eliminate this x. What we're left with is negative 4y plus 2y is a negative 2y, and a negative 1 plus 0 is a negative 1. The multiplication property of equality says that we can divide each of these terms by a negative 2, that coefficient. We could have multiplied by the reciprocal of this coefficient, but there were no fractions in this problem. So it's easier to just divide quickly. It's the same thing. So we get a positive 1y equals half. See? Now we can substitute that half for the y. We know y equals a half. We'll substitute that half for a y in either one of the equations to solve for x. So I chose the first equation, 3x minus 4y equals negative 1, and I put the half in where the y was. See? And we get 3x minus 4 halves equals a negative 1, which simplifies to 3x minus 2 equals negative 1. Now we can eliminate this minus 2 by adding a positive 2 to each side of the equation, creating a zero pair, and we get 3x equals 1. Now we can divide each term by this coefficient 3, and we get x equals 1/3. So now we know that y equals a half and x equals 1/3. Our solution for this system of equations is 1/3 for x and half for y. We eliminate one of the variables by adding the equations together to make a zero pair. That's the elimination method, okay? So this one was very, very easy because they both had the perfect numbers and variables here to make a zero pair. We had a positive 3x and a minus 3x. See that? So it automatically created that zero pair for us, didn't it? Well, sometimes the system of equations won't have a zero pair. And in that case, we can multiply every term in one or both equations by a constant to create values that'll make a zero pair. So look at these two equations. There's no zero pair here, so we're going to have to make one. If we multiply this first equation by a negative 2, we can make that 3y into a negative 6y. See? We can't multiply it by 2 because then we'll have plus 6y and plus 6y. That's not a zero pair. So we have to do it by a negative 2 to make a negative 6y. So we multiply this side by negative 2 and this side by negative 2. It's got to stay balanced. And we get negative 6x minus 6y equals a negative 30. And that's our new equation. Now we can take the second equation, put it underneath it stacked, and we can do our addition. Negative 6x plus 2x is a negative 4x. Negative 6y plus 6y, that's our zero pair that we made by multiplying all those terms by negative 2. That's eliminated, and now we have negative 30 plus 22. That's a negative 8. Now we can divide each term by this negative 4 coefficient, and we get x is equal to a positive 2. Now we can take that positive 2 and plug it in for x. I chose to put it in the first equation. It doesn't matter. You could put it in the second one if you want. But I put it in the first one. So now instead of 3x plus 3y, we have 3 times 2 plus 3y, and that gives us 6 plus 3y equals 15. We can eliminate the 6 by adding a negative 6 to each side, creating a 0 pair again, and we get 3y equals a positive 9. Now we can divide each term by this 3 coefficient, and we get 1y equals 3. So we know our solution to this system of equations is a 2 for x and a 3 for y. See that? Now what happens when we don't see an easy way to multiply them? In this, it was kind of easy to see, oh, well, 3 can be doubled and multiplied by that negative 2. But look at these. There is no easy multiplication here. So what we do is we just we pick a variable and its coefficient and say, okay, well, the 5x and the 3x can meet at 15x, but we need to make a 0 pair. So one's going to have to be a positive and one's going to have to be a negative. So we can multiply this first equation by a negative 3 on both sides, and then we'll multiply the second equation by a positive 5. That'll create a 0 pair of a negative and a positive here, see? We'll be able to eliminate that variable x. So we do this multiplication. We distribute the negative 3 into here, and we multiply the 11 by the negative 3. We distribute the 5 into the 3x and the negative 5y, and we multiply the negative 23 by the 5, and we get negative 15x minus 12y equals a negative 33, and we get a positive 15x minus 25y equals a negative 115. Now we've eliminated this because it created additive inverses, right? 0 pair. So now, adding these together, we get a negative 37y equals a negative 148. When we divide each term by this coefficient negative 37, we get a positive y equals 4. This comes out to a positive 4. Now, we're not done. We substitute 4 for y in either equation. So I chose the first equation. I'm going to multiply this negative 12y as a negative 12 times 4. We're plugging the 4 for the y, see? And we plug it into that equation, that one equation, and we get negative 15x minus 48 equals negative 33. Now we can create a 0 pair by adding 48 to each side. We eliminate this, and we get negative 15x equals 15. When we divide each side by this negative 15 coefficient, we get a positive x equals a negative 1. So our solution is x is a negative 1 and y is a 4. See? It's not difficult. It's just long and drawn out, isn't it? So it's not that big of a deal if you just slowly take it step by step. And if you can't see a 0 pair, create a 0 pair, all right? Now, both linear combinations or substitution method will always work to solve systems of equations, but when the coefficients are fractions, it's easier to use substitution method. In our next video, we're going to talk about decimals and fractions with linear combinations. And I'm going to add this video to the Algebra II playlist that you can use to study or catch up on videos you've missed in this playlist. And just click on the link and you'll see it. And there's going to be a link to the Chapter 8 from Algebra I playlist of systems of equations. And there's going to be links to the previous videos for this chapter that we've covered in case you missed those. Just click on the description and you'll see the links, okay? All right, let's see what happens with decimals or fractions when we're doing these linear combinations. All right? Keep trying. I'm proud of you, and I'll see you next video. Bye.